Alright, I'm ready. So for today, I'm tackling a question from my electrical machines and controls class. And it's under the topic of DC generators. So the question goes, a DC generator running at 25 revolutions per second generates an EMF of 150 volts. Determine the percentage increase in the flux per pole required to generate 180 volts at 20 revolutions per second. So, I got this question wrong, but we got to review the question in detail. First of all, this EMF is represented by EG. But we were told to use a fundamental formula which goes like this. P N Z phi all over B. Formula. Let me just summarize this all for you. This fundamental formula forms the general voltage equation where EG is the induced voltage, P is the number of pairs of poles, Z is the total number of conductors on the armature, phi is the flux of the poles, N is the speed of the armature in RPM or RPS, and B is the number of parallel parts in the armature. But in the context of this question, what we had to think about was we weren't dealing with either a wave wound or a lap wound armature. So what we were shown how to handle this question, how we were shown this question was handled was where we have to change the formula to consider the constants. So EG is equal to K phi N. The K is used to hold P, N, and Z. No, P, Z, just P and Z. P, Z, and B. Now that we have this formula, we can now consider the constant K. Oops, hold on. And from there, we can look at this equation and look back at the question and consider what we have to work with. We know the speed of the armature and we know the generated EMF before and after the increase. So, because of that, what we have to consider from this equation, is the generated EMF and the speed of the armature. Fortunate enough for us, we're given two values of each. So we can say EG1 is equal to 150 volts and N1 is 25 RPS. And we also have EG2 is equal to 180 volts and N2 is equal to 20 RPS. So we have two sets of values here. What we can do now, based on what the question's asking, we need to find the percentage increase in the flux per pole required to generate 180 volts at 20 revolutions per second. You know, general formula, general formula the next thing we should do is we have EG1 equal K phi N, phi 1 N1 over EG2 equals K phi 2 N2. In this equation, so because we do not have to consider the constant K in this case, we can take K out of the formula and that would leave us with EG1 equals phi 1 N1 over EG2 phi 2 N2. So because we have this, we can now find phi 1. But how? Let me show you. You have EG1 equal phi 1 over phi 1 N1. What we can do is transpose the formula for phi 1. So we can say phi 1 is equal to EG1 over N1, and that's equal to 150 volts over 25 RPS. So when we do this division, 25 into 150 is 6 times, so the answer is 6. But the unit for flux is Weber, so we write WB for Weber. Now we know phi 1, but we can do the same with phi 2 and do the comparison. So we can now say EG2 is equal to phi 2 N2, and we transpose the formula the same way. And that gives us 180 volts over 20 RPS. And when we do this, we get 9 Weber. Now we have phi 1 and phi 2. But what's next? Now we can find the percentage increase. The percentage increase, sorry. And this gives us change in phi 1 over phi 1. And the change in phi 1 is phi 2 minus phi 1 over phi 1. And that gives us 9 minus 6 over 6. And that gives us 3 over 6. This gives us 0.5. For the percentage increase now, we multiply this value by 100, and that gives us 50%. And that's the percentage increase in the flux per pole. And that's it. So I hope this helped you. My apologies for being clumsy, and until next time.